Hello everyone, welcome you all to my YouTube channel Study with Tej. Today we shall discuss on how CRC is being implemented in hardware. So basically this I have already taught you how CRC shall happen, how actually we form the code word with the data word. So how that is being implemented in the hardware, that is what we are learning today. So basically, one of the advantages with the cyclic code is that the encoder and the decoder can be easily and at very cost effective manner it can be implemented in the hardware by with few electronic devices like XOR gates and registers. So if you see here, divisor is repeatedly XORed with part of the dividend. What I'm trying to tell you is this whole thing is a dividend, okay? And a part of the dividend is being XORed. See, the XOR operation, that is what I had explained in the previous video. That is, the XOR is happening between a part of the dividend and the divisor, right? So, that is what they are trying to say in the very first point. And next point is the divisor has n minus k plus 1 bits each which either are predefined or all zeros. What it means is, I'll explain you here. See, as I had said in the previous video, looking at the leftmost bit, if it is 1, then you are taking 1 times of the divisor. If the leftmost bit is 0, then you are taking 0 times of the divisor. So either it will be divisor or zeros, that is it will be the divisor or zeros. Only these two can happen. No other bits or for other bits formation is not possible here. Either 1 times of the divisor, either the divisor itself or all zeros. Only these are two things possible while you are XORing. So that is what they are trying to tell you here. In other words, bits do not change from one data word to another. That is, see here, either this, again here it is same, or zeros only. No other data word is used. So from data word to data word, it will not change. In the previous example, divisor bits were either this or this. The choice was based on the leftmost bit. That is, as I said, if it is 1, it will be the divisor itself. If it is 0, then it is all zeros. Then again, take a close look shows that only n minus k bits of the divisor were needed in XOR operation. The leftmost bit is not needed because the resultant of the operation is always 0, no matter what the value of the bit is. The reason is that the inputs to this XOR operation are either both zeros or ones. In our previous example, if you can see here, see, E, one time we are taking means obviously we are looking into the leftmost bit and then only we are taking. So always it will be either one. So one XOR of one and one is again zero. So we are ignoring it. Even though if it is zero and zero, again it is zero only. So we are ignoring it. That is what they are taking. The leftmost bit is ignored, and only these three are taken into consideration. Next, for the next step, you are pulling the other bit down. This is what we are doing. So they are talking about the same thing. So we are ignoring the leftmost bit and we are concentrating this. So once we are concentrating this, if you can see, only this is possible or this is possible, correct? The same thing way I will tell you. Huh. So, as I had said just now, either this is possible or this is possible. That is 011 or 000 is possible. So, if you see again here, leftmost bit is 0 again. So, here this broken line, it says it is always 0 and this is ignored. As I said, this last one, the leftmost part of the dividend involved in the XOR operation, that we are leaving it just because 1 XOR 1 is again 0, 0 XOR 0 is again 0. So we are leaving that. And if you notice, this is 0 both the time. So we are keeping it as broken line. It is always 0. But the rest two are fed. Either it will be 1 1 or 0 0 depending on the left mode. But you will understand this better once I try to explain the diagram. What is augmented data word? Again, I'll go back to the same diagram. In augmented data, what they are trying to tell you is here it looks as if we are shifting towards right. That is this data word we used. Okay. After the XOR operation, we shifted. We are taking this part, right? Then after XOR operation, we are taking this part, right? That is how we are doing. So the same thing way by using shift register, we are doing it the other way. That is, first this is considered, okay, then this is ignored, and all these are shifted. That is 0 is shifted here, the 0 is shifted here, 1 is shifted here, and this 0 is shifted here. The place remains the same. Okay. Likewise, it's we are saying we are moving in the different direction, that we are moving to the left. Instead, before we were moving to the right, now we are moving to the left. That is what they are trying to tell you. You will understand it better when it is explained with the diagram. So one bit at each step we keep moving, and then we do the XOR operation. But whereas in that diagram it seems that it is moving in the opposite direction. Then when it comes to remainder, remainder is k n minus k bits only. So only n minus k registers are enough. We don't require 4 registers. So 3 registers are enough. So next we assume that the remainder is originally 000 in our example. At each time one bit will come, you do the XOR operations, then either with 011 or 00. Then after that is been done, the same procedure shall be repeating depending whether the data word is 011 or 00. And other two bits of the remainder and the next bit from the augmented data word, that is totally 3 bits are taken. In the diagram, we were taking 4 bits, but this can only be implemented with 3 bits. Why? Because as I had said, if it is 11 or 00, both the time the resultant is 0, and hence we are only concentrating on 3 bits. You will understand this better. Here, I said it has been shifting. In the augmented data word in the previous slide, I said it is shifting towards this side. So first all these three has to be shifted. So that is what we are doing. We are shifting, and by time 3 we have shifted. At time 4 already you have the augmented data word here, and depending on this, if it is 1 time or 0 time, we decide. Since here it is 1, 0, 1, 1 we are taking, and it has been XORed. If it is 0, 0, 0, 0 is taken, and it has been XORed. Likewise, we keep doing until all the augmented data word is shifted, and whatever we get last bits, whatever it is stored in the register, this will be our final remainder. So initially we start with 00, and finally whatever the remainder is obtained, that is augmented with the data word, and that becomes the code word. The same thing here in the previous example, if you can see, there are so many XOR gates and so many registers. This can be written as this in very, I mean, the same operation is happening often. So here only 3 registers are enough, and 2 XOR gates are enough to do the same old operation. The same thing they have tried to say here, that is encoder or a decoder. If we have, depending on the number of bits in the data word, that will do the job. So in general terms, it is given like that. This was a specific term. The same thing in general, they have given it as like this. So this is the general design of encoder and the decoder. Thanks for watching.